Hey viewers, wanted to do a quick supplemental video here. There's a lot of reoccurring comments that I figured that I'd just try and address it all in one spot in this video. This is a series of videos. I haven't had the chance to actually go to all the description boxes and make sure that every description box has all the information that people keep asking for repeatedly. And it seems like a lot of people just aren't looking at the description boxes. I'm not sure how better to do that, how better to communicate the information. So I'm just going to create this video to kind of answer a few different concerns or questions or points that people keep bringing up. And hopefully I can just refer people to this video. I am going to try and update the description boxes for the whole series of the curved water series so that all the information is more readily available, but I'm also going to just try and show you what's out there. First of all, I'm a big believer in free speech, so I don't censor comments, but for some reason YouTube does, even though I have the community settings open to like completely wide open, except for some, a few just things that we don't, need going on in the comments. I mean, it's wide open, so I don't know why they're being censored. I try to take some time throughout the day and come over here and, just basically mass approve everything. But I mean, look, I just mass approved it a second ago, and here we are again. Like I can't keep up with this. I don't know why YouTube is doing this. So if anybody has a suggestion, please let me know. Yeah, I don't know what's going on here. This isn't even the right page. Ooh, how do I approve that? Likely spam 10. Something's wrong. I don't know. YouTube got it all borked right now. But anyway, I mean, I'm trying to approve every comment. If you post a comment and it doesn't get posted, this is what's happening. I don't know why it's doing this. It's really aggravating. I wish it would just approve everybody's comments. I'd rather just be wide open, and then I could just go delete anybody that's being abusive. That's my preferred approach. But I don't know. Anyway, so on to other matters. People keep bringing up lens distortion. I'm on Twitter. You can go look at this post if you want. I also have created this folder, which I linked to. I'm pretty sure I've linked it to every video now. This folder has all the raw data in it. In this folder, I've taken pictures of a test grid at full 300mm zoom, so you can see what the test grid pattern looks like and what type of lens distortion my lens has, and there isn't any. I mean, it's not a good lens, but it's not terrible either. I mean, there's not going to be some magical lens distortion that's causing this. You can see with your own eyes, guys. But anyway, I overlaid the lens distortion on one of the images, so you can see that it's not at all related to lens distortion. There's actual curve there. People keep bringing up atmospheric lensing. Atmospheric lensing is not a term. It's a term that's used by flat earthers, and in my opinion, it was created to identify flat earthers. If you use that term, they know that you've been thoroughly brainwashed. It's atmospheric refraction is the term you're looking for, and atmospheric refraction generally, on average, causes objects to be seen higher than they normally would. There are occasions, obviously, where the light is bent up, and we typically refer to those as mirages. There's all types of different atmospheric conditions, but there are also average atmospheric conditions. That's why I've gone out here on multiple occasions in different situations, in different atmospheric situations and scenarios, and taken pictures, so you can see that the curve is in fact there, regularly. It's always there. So I invite you to look at this folder, do your own analysis. I've even shown you what gear I use, all the images, the raw images especially have all the metadata. JPEGs have the EXIF metadata. I mean, all the information is there. So, and oh, location information. There, I have pictures in here with location information. The GPS coordinates are on here. I mean, go look, do a little bit of investigating, guys. I can't constantly be answering the same question over and over and over again. Now, one question that does come up repeatedly is this question about why can't we see curvature on the horizon yet we can see this curvature here. Well, I've actually already answered this question in a Hangout that I did a couple days ago. I'll go ahead and repeat it here. I have linked that Hangout in the description of most of the videos. Again, I've tried to be thorough about that, but basically, the reason you can see this curvature, and this is something that we've always, all the globe guys, and for some reason, you know, flat earthers are saying we've never said this, but we've been constantly trying to tell you guys that the way you see curvature is in this direction. This is the way you see curvature from the observer out over the horizon. And the reason for that is that this tower right here is 16 miles away. So from this tower to the observer, we are compressing 16 miles worth of curvature into just a few pixels. I mean, you can come in here and just do a little bit of analysis and count these towers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Try and keep, oh, well, shit. I should have done it the other way. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Can I zoom in without losing it? Yep, 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. About 28 towers before we kind of lose the rest of the towers in a blur. Okay. Well, there's 80 towers on the way to here. So you have basically 50 towers that are all compressed into this very small amount of pixel space. And that 50 towers, you know, so that's over half of that. That's over half of that 16 miles. So we're talking about at least 8, probably 9. I don't know. I'm just throwing rough numbers out there. 9 miles compressed into, you know, this is 100 pixels or something. I mean, it's not even 100 pixels on the original image. I don't know. It's not very much. A couple hundred pixels maybe. So that's why, you know, that's why you're seeing the curvature, because all that curvature is being compressed. You can do a very simple, experiment yourself. Take a clothesline, string it up between 2 poles that have enough distance, and create a, create a representative of this. Hang clothespins. Try to keep it to scale. Hang clothespins equal distance, 80 of them on this line. And make it to scale with this example here. Pull that clothesline as taut as possible. Of course, leave a little sag in it. It'll probably already have a little sag anyway. And line up down the line and take a picture. And you will see this type of curvature. I mean, that's what you'll see. That you'll see curvature because it's all compressed into those few pixels. You can do this experiment. Experiment yourself. You can set up a sample experiment for yourself. So I think that addresses pretty much everything. Yeah, it's not lens distortion, fellas. I mean, you want to argue that because you really don't want to see a curve, but it's there. There is a real curve. It's not lens distortion. It's not atmospheric refraction. It's an actual curve. And here's the thing that's really important to think about. There is a conventional model out there. There's actually a survey from 1984, and there's a model called the WGS84. That is the conventional model. So when you start using this 8 inches per mile squared formula incorrectly, you're not debunking the conventional model. You're debunking some straw man that you've invented in your head. 8 inches per mile squared literally means that you have buried yourself in the ground and half of your eyeball is underneath the ground. That's the only way that that measurement is valid, because it doesn't take the height of the observer into account at all. Now, I've discussed this ad nauseum with people. So what I'm going to do is I'm going to refer you to this page on my spreadsheet, which I've also linked in all the descriptions. There's a YouTube video that explains how I derived this formula right here. Okay? But the important thing that I want you to realize, and that I made a point of in this video, is that this 8 inches per mile squared maps to zero height. Okay? This is zero height with refraction included. This is the 8 inches per mile squared. So it doesn't even map to zero height because it doesn't have refraction included. So it's not even zero height. It's like you'd have to be less than zero height for that formula to make sense. But nobody's at zero height. Okay? That's just not what happens in reality. Okay? We're at least 6 feet, right? Unless you're a below average male, then maybe less. But pretty good 6 feet, okay? This particular observation was somewhere between 30 and 40 feet. Now, Dazza gave me a pretty good, rational, Dazza and Sean gave me a really good rational reasoning for a guesstimate about where I was, and they came up with around 33 to the top of the highway. So that puts it at 6 foot. A 6 foot observer sitting down in a car, say a 4 foot observer on top of the highway, so that's 37. Okay, so between 30 and 40 feet is this observation at 15.9 miles. Okay, so we're talking about 32 to 42 feet of obstruction. This is what the conventional model predicts. Okay, so you guys want to talk about hundreds of feet that are hidden? It's just wrong. It is wrong. That is not what the conventional model predicts. Conventional model predicts this, somewhere between 32 and 42 feet of that very end tower, which is a 210 foot tall tower being obstructed by the horizon. I mean, let's go back and look at the video. Not the video, but the image. Okay, so speaking of what you're saying is if you don't show me a video of you zooming in, then things would come back in over the horizon. No, things don't come back in over the horizon. That's not how light works. There is an image being presented to your eye or to whatever device is sensing the light. There's an image being presented there. All magnification does is scale the image. It does this. That's all magnification does. Now this is essentially equivalent to a digital scale, so you're not going to get higher resolution. But it's the same exact effect. This is what would happen. If I had an optical zoom and I zoomed in, it would just scale up. It's all magnification does. So stop saying things come back in over the horizon. That is a lie, and it's an obvious lie. There is no rational reason why we would believe that somehow a lens can magically make light 16 miles away change its path. Think about that. Your eye, your camera are passive receivers. You're receiving sensory input from the light that arrives at your eyeball or arrives at your camera. How can magnification change the light that's arriving? It doesn't. Light's still arriving. It doesn't know anything about magnification or care. It's just arriving. It's always there, arriving. It's just an image that you can zoom in on. That's all it is. So it's just so patently absurd to make that claim that I don't understand how anybody can make that claim with a straight face and actually believe it. I mean, I really do have to believe that people that say that they're zooming in on the horizon, pulling things in from over the horizon, they're just trolling. They have to be trolling because it's so patently false. I don't really want to go on a rant. I mean, I am kind of ranting a little bit because it's just frustrating answering the same questions over and over again. But yeah, I invite everybody to check out the spreadsheet. There's a lot of like very useful information, a lot of good calculators and stuff. So the important takeaway point is that there is a conventional model, and that conventional model makes predictions, and that's the important thing. What predictions does that conventional model make? Are they falsifiable predictions? Because if you're falsifying, or if you're trying to show that things are false that aren't part of the conventional model, then what are you disproving? A straw man? You haven't done anything. You've basically deceived people into believing you've somehow falsified a conventional model that you didn't. So 32 to 42 feet, constructed of 210-foot tower. That's what we're seeing. We're seeing curvature. We're seeing the predictions of the conventional model being played out in these photographs. And that is the truth. Now, why those predictions are being played out? Is it because the conventional model is correct, or is there some elaborate scheme that can explain the scene that we're seeing that isn't the conventional model? That's what flat earthers want us to believe, but that's not what, I mean, you have to come up with something rational. You can't just keep spouting the same talking points. Atmospheric cleansing. Anytime I hear somebody say atmospheric cleansing, I know. I know where they're getting that from. It's Rob Skiba. I mean, come on, guys. You're repeating the same words, and you don't even know what they mean. Atmospheric refraction is what you're looking for. It's well known, well understood. There's a whole field of engineers that work with it. They're called geodesists. Now, these guys are experts at taking measurements. Do you really want to say that they're all idiots, dumb, fooled, con men, part of the big conspiracy? Is Jesse Kozlowski trying to fool me into thinking the world is round? Why would he? I don't think so. Regardless, you can go do the measurement yourself. And that's what Jesse Kozlowski suggests, and that's what all of us suggest. Go do the measurement yourself. If you actually do the measurements yourself, you will realize that there are things that absolutely 100% falsify the flat model. And we discuss them ad nauseum. We got guys doing experiments out there because they actually care about humanity. They actually don't want people to be deceived and fooled. Wolfie, Daza, Sean, Five Red Pears. I mean, we're all out there doing the experiments, doing the math, actually providing real evidence to try and basically present the rational reason side of the story. And what do we get for it? We get ridicule from flat earthers. We get called shills. Well, I've been called a shield so many times that word has no weight anymore. That word means nothing. I even made it part of my avatar because it's a joke now. I mean, I'm a shield, really? I'm getting paid by NASA? I wish I was. I wish I could do this full time. Debate anti-science guys. I wish somebody would pay me to do that. But no, I do it on my own in my free time because, I think about my kids. I think about my nieces and nephews. I don't want them to be fooled by this con. I don't want them to be deceived. And that's another thing that's really frustrating to me. Well, you're supposed to be, most of the flat earthers claim to be Christians. You're supposed to be representing this faith that claims to be the foundation of truth. But in order to do that, you have to lie repeatedly. Flat earthers lie repeatedly. That is not the heart of a person that's seeking truth. That is not. You're discrediting your faith. And that's the truth. And everyone that's falling for it, that's listening to these charlatans, you're following false doctrine. You're following false teachers. So if you're a Christian, heed that warning. I hope you do. All right, enough ranting from me. Soundly out.